All right, everyone, welcome back. High knowledge, whatever that may mean, on wireless access points. Okay? Even though I do have a wireless class, all right, that explains everything in detail. But let's see. Defining access points, because the old exam took out wireless. Now they want to put it back. What is an AP? The name says it. It's an access point. It takes all the wireless devices around it, puts them together, and you're accessing normally a LAN. You can do it because you don't want to run wire. You can do it because you can't run wire to where you're at, so you have no choice but to do things wirelessly. Okay? So these are the reasons that you want to go ahead and do it. Now, there's different type of APs. There's some APs with one antenna, two antenna, or multiple antennas. You have some APs with no antennas. All right? The antenna is already built in, just like your laptop. It's in the screen. Okay? So the Linksys access points / routers, the difference. Okay? They have already antennas built in. They used to before had two antennas. All right? But when we talk about multiple antennas, meaning more than two, we're talking about MIMO, multiple in, multiple out. All right? You can have two APs, but that will be considered or referred to as diversity. And I explained that in my wireless class. Okay? Which this is not it. All right? Diversity. All right? APs give you wireless devices access to the wired network. I already said that. Type of APs. You have the plain Jane standalone AP. All right, which is just all it does. It has really no real features. All its main job is just to connect all the wireless devices and then connect them to the LAN. Or you have the router AP, which is what we normally buy at the store. Everybody goes, hey, Mr. Whatever, I want to be able to go wireless in my house. Can you sell me something? And then they go straight for the Linksys or the D-Link or whatever it is that they're told to sell that day, okay? And then they sell you a router. And then, of course, you're going to say, oh, and this one is going to be a lot faster because it has extended range and it has all these different things. And it's just basically cash, all right? That's all it is, okay? So the router you would want, obviously, because it has features that the access point does not. Okay? Dhcp, NAT, radius, which is in the wireless class. Encryption, right? Meaning you put in not only SSID, change the SSID, which means what? Security set identifier. Not only what you connect to, but then when you connect to it, you have a passphrase, correct? You're going to use AES encryption. All right? So you decide what encryption you're going to use. And then even a very, very basic firewall options. Very basic firewall options. And also, let's not forget, MAC filtering. We know this. We know this. All right? Now, you need to know your standards. When you're out shopping, you know where you go. All right? 802.11 definitely is obsolete. We do not use that anymore. Runs at the 2.4 gigahertz range and 1 to 2 megabits per second. 1 megabits per second is using frequency hopping spread spectrum. If it's going up to 2 megabits per second, it's going to use direct sequence spread spectrum. Okay? Direct sequence spread spectrum. It's hard to say, like a tongue twister. Okay? But we don't use 802.11 by itself anymore. Then you have the 802.11a, still in use today. Why? Why do we still use it? And why it really hasn't, everybody hasn't said, man, I think we should use that. I think it should be better. 5.8 gigahertz. What do you think the difference may be there? Besides the obvious, which is speed, okay, 54 megabits per second, because every last device in your home that's electrical runs at 2.4 gigahertz range. So you're gonna have interference. Your microwave, all right, will interfere with your wireless signal. All right, your appliances, your TV, everything, all right, are gonna run into, not your oven, obviously, okay, but you know what I'm talking about. All right, they're gonna interfere with your 2.4 gigahertz range. So if you're on 802.11a, it's 5.8. Bottom line is they're kind of hard to get and they're costly. All right, but 54 megabits per second, and the type of modulation, which means the intelligence that it puts on the carrier wave, is OFDM. OFDM, all right, which is the latest one. All right, so you gotta be, that's why it's still used today, but normally companies are the ones that use that. All right, 802.11b, still used today. It's backward compatible because we use a lot of GRN, so it's got 2.4 gigahertz, unfortunately. 11, so you got, I'm gonna stand over here. You went from 5.8, hard to get, 802.11a, business use it, 54 megabits per second, a hell of a modulation. Okay, then we have 2.4 gigahertz. Here we go again, back to interference. I mean, you live close to a power line, you're pretty much out of gas. Then you got 11 megabits per second. We go down, way down. And now the modulation is CSMA-CA. Are you serious? Now I gotta start polling and see who gets there first to see when I can have access to what I need to have access to. All right. So they made an improvement. They went to G. Why they skipped C, D, and E? I don't know. But they went to G. All right. 11 megabits per second. 54 megabits per second. Sorry. 54 megabits per second. 11 to G. Now we got the speed back up because they changed the modulation. Type. All right. Now, which is what I have, or no, not there. I do have N, but I switched over to AC, which is one of the latest standards you need to know. And believe me, there's a whole alphabet waiting for you. If you go and look up the IEEE, it's a whole alphabet. Okay. 802.11n, it is more prominent, okay, because it runs on both bands, 2.4 and 5. So you can actually run both at the same time. So if one's not working, you can connect to the other one. All right, which is kind of nice. I did that in my old place. I actually ran both, okay, and it runs at 54. But you have the MIMO technology, multiple in, multiple out. So you have multiple frequencies going out because of multiple antennas to get to where you need to go. And believe it or not, I still needed to use an extender, okay. And then you have what I have now, which is the AC, which promises gigabit speed, but it runs at the 5 gigahertz only, and is up to 433 megabits per second. Doesn't say anything about modulation. I may look at it later on and find out and give you guys an update. But I can tell you right now, I have not seen gigabit speed yet, but the speed is not bad. Now, when I talk about wireless, one of the very first things when I started teaching wireless many moons ago, they said that all manufacturers need to be the same. You can't have a D-Link wireless card, NIC card, and then buy a Linksys wireless router. Okay? Do not mix and match. If you're going to go D-Link all the way. If you're going to go Linksys all the way. If you go Netgear all the way. It all depends on what you want to use. Okay? But keep the same manufacturer. Okay? Keep the same manufacturer. Especially when it comes to wireless. Now, we do have a lab here, a very simple lab. Okay? We do have a lab here. All right? But you need to know at least these standards. Okay? Now, the next thing. I don't know, I'm just in shock. An independent basic server set, an IBSS, if they ask you questions like this, there's no AP. None. That's what's called an ad hoc network. An ad hoc network, which means two devices, two laptops, two computers, desktops. They have antennas, NIC cards built in, or you put them in, whatever the case may be, and they talk to each other. So you have an ad hoc network. I have no idea who uses that. Okay. Basic service set. You have one AP. That means all your wireless devices connect to this one AP. Now keep this in mind. Okay. One AP, depending on the type of traffic that you have, can handle anywhere from 25 to 50 devices. If you run an architectural company, a surveying company, uses plotters and sends images, all right, very large images, and you're sending them wirelessly, that could run into an issue. It could be even less than 25. Okay? You can bring it down. So you gotta think about what you're doing. So if you're doing something like that, and I will go wired, number one. Number two, if you are then do an extended service set, which means you have more than one AP. You have more than one AP. You have two actual routers, or three or four or five, whatever it may take. All right. So you can go ahead and speed up the process, make it more powerful. Okay. What is it you need to know right here? Know the abbreviations. Know the abbreviations. Know what the abbreviations mean. Okay. When you're doing a wireless network, again, I'm not going to turn this into a wireless class. All right. You need to understand where you're going to first. My first wireless network job, I thought I was the man. I just went in there and said, "Oh yeah, no problem, no problem." Just walked in, said, "Yeah, we're gonna put the wireless access point in the closet." I just totally ignored the fact that there were like 4 other access points in there. Okay, and there was all sorts of electrical equipment in there. Totally ignored it. And of course I did this on a Saturday when there was nobody working. Put the access point in there, connected to their switch. I didn't connect it to their switch. Well, yeah, connected to their switch, they can go outside. And then I went ahead and connected their computers to that access point. Boy, they can print, they can go online. They were speedy. They're loving it. It was great. Until Monday showed up, and everybody came to work. They were getting not even 2 megabits per second. Naturally. Why? Because they, when all those access points went to work, and they're all working on the same frequency, okay, and all the electrical equipment around it are causing interference on top of the access point causing interference, they weren't getting anything. So the placement of your access point is extremely important. That's why you do something called a site survey. There's also something called a physical site survey and a radio site survey. The physical site survey is when you go, check out the campus, and you say, okay, the ceilings, all right, it's all concrete. All right, I have no tiles or anything like that. All righty, this is how far apart the rooms are. This is how big the campus is. And then you do your radio site survey. You have an actual device that will detect wireless networks and the strength of that signal. See if there's any dead spots that you need to cover. And you do that. So after you do your physical site survey and your radio site survey, then you go and say, okay, I'm going to design now. I need 4 access points in order to cover the whole thing, plus maybe a little bit in the parking lot. At least that's the way it was in my college. All right, because everybody in the parking lot is doing their homework before they come into class. That's the way it was. And then they can print it out right from their cars. So that's what you had to do. So there's just more to it than just going down to the local store, buying a router, just to mention one, a wireless router, slap it in anywhere under the receptionist desk, and let bygones be bygones. It doesn't work that way. That's why I keep telling you, no matter what you do in networking, design is the most important thing of all. Okay? Now there's the lab we're going to do. Basic lab. We have a wireless access point. Okay? And you can see that they're connected wirelessly. We have a tablet, we have a PC, a laptop, and then we have a switch, and then we have a server. You can see that they're connecting wirelessly to that router, okay? And then the router is connected to the switch, which then gives them access to that particular server. That's the whole point of an access point. But don't get it confused, because people say, hey, I need to buy an access point. The person that you're talking to at the local store hopefully knows what you mean, but 9 out of 10 times they have no idea what they're talking about. Okay? There's a difference between an access point and a wireless router. An access point, that's what it does. One port in, one port out. That's it. It access just, okay, wireless people come in here, and then I'm just going to connect you guys to the wireless wired LAN. That's it. I believe, if I'm not wrong, if memory serves me correctly, it is more expensive than a wireless router. Even though the wireless router gives you a lot more feature set than an access point. So be very careful. Let the buyer beware. All right, when they go buy their stuff. So with that said, let's go ahead and go into a lab. It's going to take us like 30 seconds to configure this thing. It's ridiculous. All right, but we're going to do it anyway. I'll see you inside. All right, here we are in our wireless lab. As you can see, I threw out there some devices that are wireless. We have a wireless router, a switch, and an actual server. Because we talked about that the wireless is real, or the access point gives wireless devices access to the LAN server, service, network, whatever. All right, but it's not. It doesn't do it by default. It just doesn't automatically do that. Number one, on the tablet, you don't have to change anything. It's already built in. You can see there's no modules whatsoever on here. It already has it built in. All right, and all you really have to do is a wireless 0 configuration. All right, the SSID, or the security set identifier, has to be the arena, altogether lowercase. You can use whatever you want. This is what I used. All right, but they have to be the same on the client device, on the end device, and on the networking device, which is the router. And then the WPA2 pre-shared key is going to be Spartacus, right? So they all have the same exact thing. They all have the exact same thing, all right? So that's why you see these lines, these frequencies, right? Because we're using 2.4 gigahertz. All right, and what type of topology would this be? This would be your, not independent, but basic service set. Basic service set, because you only have one wireless router. All right? One wireless router, BSS. So if you go into your router, and let's open this up a little bit here, or quite a bit, I would say, so you can see what it is. It looks just like a regular Linksys router. Okay, if you go to the GUI, which is nice, one of the things that I did change was the IP address. I changed the IP address. All right, I left the mask as it was. I did enable the ACP, but I changed where the IP address started, and I changed the number of IP addresses. Okay, I didn't have to do anything with DNS, WINS. I don't know why it's even still here, but I don't do anything. I'm not doing anything with DNS. All right, and before, if you do any changes, remember you got to go to the bottom of the page and save settings. Save settings. If not, it gets erased. All right, then I go to wireless security, and that's where the SSID gets configured, and that's where I put the arena, and I do broadcast my SSID. I do broadcast it. Some people say don't broadcast it, but then that means that you will need to configure everything manually everywhere. I do broadcast my SSID. Okay, and then wireless security. This is where I put my passphrase. You either have AES encryption or TKIP. I use AES. TKIP is weaker than AES, so therefore I use this. In my wireless course, if you were to do I do WPA2 Enterprise, which is Radius. But we'll be learning about Radius in ICND2 portion of this new topics section. All right, which we will configure TACAX and Radius. All right, we could have done MAC filtering, but we can't. I didn't. If, it says prevents PCs on the listed below. There's nobody, no PCs listed. It's not preventing anyone. Or permit PCs on the list below. So you can do either or. Okay, and you do have, there's security right here. This is your little firewall that you can use. Access restrictions based on time and day, or URLs, keywords, ports, applications, and so forth. So there's different things. This is the advantages that we were talking about when you get a router. And most definitely administration. Change the password of your router. Don't leave it the default, which is probably Linksys, okay, or whatever, or D-Link, or whatever it is. It's on the internet, so you can Google it. All right, so don't leave the default, change it to something funky. All right, and save your pages as you get out. But once you got that done, that's why these guys were able to actually, if I was to go here, it's DHCP. They got an IP address and a gateway from the actual router. Okay, now this right here is connected to the 01 because the 00 is reserved for the internet port, and we don't have internet, so we're not plugging into that. So I plug these in here, and if you look at the server, if you look at its IP address, he's getting an IP address as well from that particular router in that range. So we're all here part of the same network. All right. Maybe these are in a particular location where wires can't be run, and that's why they have to be wireless. Okay. But you can see the difference because APs really, I think I have one here. Let me see, wireless devices, generic wireless device, generic cellular tower. I have a CO. I think these act as access points. These generic ones here, yeah, access points, and really they don't really do much. I mean, their configuration is port 0, port 1. There's only 2 interfaces. Their purpose is basically to extend the network, to just give access. There's no security in them or anything like that. So you want a wireless router. But this is it. This is your wireless router configuration. But again, if you want to get into more detail, all right, on wireless, I do have a wireless course that's out there that goes into a lot more detail than this, because really there's nothing to this, all right, because the course gets into the controllers and everything like that, and it shows you step by step. This is the access point lab, because there is no wireless controller lab. This is a wireless access point lab, which is really nothing. It's very simple. And again, things you're going to be asked is, what type of topology is this? You know, what is the SSID? What frequency? Things of that nature. Very basic. I don't think it's going to get too deep, but we shall see. But again, this is your wireless lab. Alrighty. It can't get any simpler than that. Okay, it cannot get any simpler than that when it comes to this. All right, we put out our wireless controller, we put in the same SSID, we put in the same pre-shared key. You saw it was WPA2 personal, not enterprise. All right, because enterprise, then we have to set up a radius server. If you want that, get the wireless course. It's going to teach you everything you need to know about everything. Okay, so you got that right there. All right, PS, they share this. Once you share this, once you put in the same SSID and you put in the same pre-shared key, boom, it all connects automatically. You want to change the DHCP default addresses. You want to change the default SSID, and that's one of the major security issues that people don't understand. Okay, that you need to do that. All right, we saw that we didn't do any MAC filtering. Okay, but you can if you wanted to. You saw the basic firewall, there are filters, okay, that you go ahead and put in there. The time of day they can do, you can have websites you can block, you can go ahead and put whatever it is, okay? And please change the administrative password for the router. Why would you change everything else and not change the password for the router? I can tell you what I did. I was a bad boy. When I would teach my class at the college, I would take them outside. And we would walk around with the laptop. And we would say, okay, see how many wireless networks we can get a hold of. So we would walk around. I said, oh, look, we have a wireless network here. Let's see if we can connect to it. Boom, we connected to it. I said, you know what? It's a Linksys password. And we know the default password, so we typed it in. Guess what? We were in. Yeah. And then we would change the whole network scheme altogether. So we were in, but they were not. So you see what I'm saying? I wasn't trying to hack their thing. I didn't care about anything that they had or anything like that. But the point is, somebody can mess you up really bad. Okay? Just by that alone. Because they can get into your router and they can change all your settings. You don't want that to happen. Okay? You don't want that to happen. So the lab was pretty simple. Nothing out of this world. You know the key points. You know what's important. Okay? You know now the differences between IBSS, BSS, ESS, all that good stuff. Know the difference between access points and wireless routers. They're not the same thing. They're not the same thing because of the features that they bring. All right? Enough said. See you guys in the next one.